Here's the graph of the function f of x equals x squared. For any given value x on the x-axis, we get a y value back, inserting the x value into the function. X equals 1 is paired with y equals 1 squared, which is 1. 1, 1 is a point on our graph. X equals 2 is paired with y equals 2 squared, which is 4. So 2, 4 is a point on our graph. X equals 3 is paired with y equals 3 squared, which is 9. So 3, 9 is a point on our graph. Consider this second function, g of x, which is equal to x squared plus 5. What are the y values of this second function for the same three x values we selected? X equals 1 will be paired with 6, x equals 2 will be paired with 9, and x equals 3 will be paired with 14. What do you notice about the y values of my second function when compared to the y values of my first function? The y values of my second function are all 5 higher than the y values of my first function for the same values of x. In fact, for each value x, the second function's y values will be 5 higher than the first function's y values. Well, what is the difference between these two functions? This plus 5 right here. In the second function, by adding 5 to the first function, every y value is shifted vertically by 5 to get from function 1 to function 2. Adding a constant to any function shifts the y values of the function vertically by the value of the constant. Consider all of these functions. If I wanted to create functions of each of these that shifted each one vertically by 10 units, I'd create functions that look similar to them but add a constant of 10. If I wanted to shift them down 10, I would subtract 10 from the original functions to shift them vertically down 10. Mainly, vertical shifts of functions come from adding or subtracting a constant to a function. Consider the function f of x equals the absolute value of x. Here are two examples where the function is shifted 5 units either vertically or horizontally. Which one is the vertical shift? Well, the one with the 5 outside the absolute value function is the vertical shift. This function shifts the absolute value of x graph up 5 units. This one shifts the absolute value function to the right 5 units. Consider all of the functions x squared, x cubed, the absolute value of x, and the square root of x. For each one of these examples, adding a constant to the argument or input within the function is a horizontal shift. For example, here are all of the functions shifted to the left 3 units. Also, adding a constant to the final result of the original function is a vertical shift. For example, here are all the functions shifted down 3 units. With a little bit of practice, you'll be able to identify a horizontal versus a vertical shift. If you need a refresher on horizontal shifts of functions, check out this video here. I'm Joe, and thanks for spending some time with me.